Hi there, this is Estelle Trengove and this is my video on how to use supernodes in nodal analysis. Remember that for nodal analysis we write down Kirchhoff's current law at each node and then we write each of those currents in terms of the node voltages and the resistances. So at node V1, by Kirchhoff's current law, we've got flowing into the node a current of 1 amp, and we've got flowing out of the nodes currents I1 plus I2. So by Kirchhoff's current law, I1 plus I2 must be equal to 1 amp. Now we're going to write I1 and I2 in terms of the node voltages. So you can see current I1 is flowing along here. It's flowing from V1 through the 3 ohm resistor to V3. So 1 amp is equal to V1 minus V3 divided by 3 ohms plus, and we can see here that I2 is flowing from V1 to V2 through the 1 ohm resistor, so it's equal to plus V1 minus V2 divided by 1. And now we're going to multiply that all by 3 ohms, so we get 3 volts is equal to V1 minus V3 plus 3 V1 minus 3 V2. And if we gather like terms together, we get 4 V1 minus 3 V2 minus V3 equals 3 volts. And that's the first equation that we need to solve for all the unknown node voltages. At node V2, we can write I2 in terms of node voltages and resistor, and we can write I3 in terms of a node voltage and a resistor, but we don't know what the resistance is of this 8-volt source, so we can't write down a current here in terms of the node voltages and the resistance. The resistance of an ideal voltage source is assumed to be 0 ohms. Our problem is that we now only have one equation and we still have 3 unknowns, V1, V2, and V3. And we solve that by defining a supernode. Remember that our 0-volt reference node is at the bottom here. So we define a supernode as a voltage source that is between 2 non-reference nodes. So in this circuit, this is the supernode. And now we just find Kirchhoff's current law at the supernode. So by Kirchhoff's current law at the supernode, and if you look at the supernode, you can see we've got I2 flowing in, we've got I1 flowing into the supernode, and we've got I3 and I4 flowing out. So we can write I1 plus I2 flowing into the supernode is equal to I3 plus I4 flowing out of the supernode. Now we follow the same process, so we can write I1 as V1 minus V3 divided by 3 ohms plus I2 is V1 minus V2 divided by 1 ohm, and that's equal to I3, which is V2 minus 0 divided by 2 ohms plus I4, which is V3 minus 0 divided by 10. And if we multiply by 30, then we get 10v1 minus 10v3 plus 30v1 minus 30v2 is equal to 15v2 plus 3v3. And if we gather like terms together, then we get 40v1 minus 45v2 minus 13v3 is equal to 0. And that's the second of the three equations that we need to solve for the three unknown node voltages. The third equation comes from observing that the 8-volt voltage source is between V3 and V2. Its higher voltage is on the side of V3 and its lower voltage at the side of V2. So we can also write at the supernode V3 minus V2 is equal to 8 volts, and that's the third equation that you need to solve for this circuit, and the rest is just maths. That's the end of this recording.